Howdy doody, here we go. Day 2, special right triangles. This is called solving a right triangle, which simply means we find all the missing angles and all the missing sides. And we're going to use either special right triangles, Pythagorean's theorem. We could do it with trig. Today, we're just kind of practicing what we learned yesterday with the 45, 45, 90s. Okay? And here we go. All right. So the easiest angle to find is U. How do we know? Because if this is 45, this has got to be 45. Easy peasy, lemon squeezy. All right, now to find the two missing sides, we say, hey, these are the legs. And remember, it was a 1, 1, square root of 2 ratio. And we can do it two ways. We can set up a ratio and proportion, or we can say, hey, what do we multiply by 1 to get to 5? And we simply know that this leg has to be 5. If you don't remember that, we can simply set up a ratio and proportion and say, hey, 1, the original leg, compared to VW that we don't know, is equal to square root of 2, the hypotenuse of the original, times what we do know, 5 square roots of 2. Cross multiply and solve. 5 square roots of 2 times 1 is 5 square roots of 2. And the distance of VW is VW times the square root of 2. How do we get the distance of VW by itself? Simply divide by the square root of 2. And the distance of VW is nothing more than 5. Another way we could have looked at it is we said, hey, if we know the leg times the square root of 2 equals the hypotenuse, we could substitute in what we know. 5 square roots of 2 is the hypotenuse. And solve for the leg. And if one leg is 5, then we know that the other leg has to be 5. All right, this is nothing new other than we're finding a missing angle and the legs. Again, it's a repeat of what we did yesterday. Same thing here. Hey, if we know that this angle is 60, then we know right away that this angle must be 30. Easy peasy, lemon squeezy. The hardest part is identifying what are they giving me. And in this problem, they're giving me this length, which is opposite of the 30 degrees. So they're giving me the small side. And if they're giving me the small side, we know the small side is 1. The medium side is square roots of 3. And the hypotenuse is twice as big. We can set up proportions to solve, or we can use the multiples to solve. The small side is square root of 34. And we know that the hypotenuse is twice as big. So the hypotenuse is 2 times the square root of 34. We could have also set it up 1 over the square root of 34 is equal to the original times or over what we're looking for. H times 1 is H, and then simply multiply 2 square roots of 34. 4. Okay, the medium is a multiple of square roots of 3 times the small, or the small times square root of 3 equals the medium. Again, we already know what the small is. The small is the square root of 34. So the square root of 34 times 3 equals the medium. Square root of 3 times the square root of 34 is the square root of 3 times 4 is 12. Carry the 1, 102. Now, if it can be reduced, you can reduce it. So we want to look and see, hey, can we reduce the square root of 102? I know the square root of 3 can't be reduced. Can the square root of 34 be reduced? The only number I can see that 34 can be reduced by is 2. 34 divided by 2 is equal to 17. 17 is not reducible. You cannot take the square root of 2, so this is your final answer. It can't be reduced. That's it. Basically, you're just practicing and finding all missing parts today. All right, guys, knock yourselves out. You'll do a good job. Talk to you later.